So the ability to, have these two variables completely independent of each other, and the fact that this is an assignment statement leads us to do some interesting things, like being able to update variables as they change, right? So this might look a bit scary, but it's not. Remember, this is the cardinal rule to remember. Evaluate the right side and assign it to the left side. Figure out what's on the right side and store it in the variable on the left, no matter what it is. Right? So if we do b is equal to 3, a is equal to, let's say, b plus 1. Okay? Print a. So a's value was 5, b gets the value of 3, b gets the, and here we say store inside a b plus 1, and this will overwrite the old value in a. So b plus 1, that's 3 plus 1, so that's 4. Save it, run it, boom, 4. Okay. Switch it to 5. A is equal to 5, b is equal to 5. A is equal to b plus 1. So figure out what's in b, what's b plus 1. What's in b? It's 5. Add 1 to it, that's 6. Takes this evaluates to 6. Store it in a. Okay. A is equal to 5, b is equal to 5. A is equal to a plus 1. A is equal to a plus 1. A plus 1. Well, the same rules apply here. Figure out what's on the right side and store it in the left. So, what's stored in a at this point? Well, a is 5. Add 1 to it, and we get 6, just like we had with b. So a had 5 in it. We figure out what's on the right side first. So a had 5 in it, add 1, we've got 6, store 6 in a, and we've got the value, we've got the value 6. Alright, let's go ahead and copy and paste this, right, just to belabor the point. 6. So here we have 5, add 1 to it, and we store that result in a. So 5 plus 1, 6, gets stored in a. So a is 6. Now, what is a here? A is 6, add 1 to it, store it in a. A is 7. Right? And part of this impermanence is actually much easier for us to keep a mental model of when you're programming. This whole not keeping a binding between a and b, right? B is equal to a, right? Same thing still applies here. B and a are independent, right? You just simply copy the value over, because wouldn't it be a pain to have to remember, wait a second, oh right, this updates all the time. You know, that would be a pain if we had to keep thinking, oh, okay, B keeps updating every time we update A. It doesn't. It makes it easier for us. So here we take A, figure out what the value is, and add 1 to it. A plus A. So here A's value is 6. Alright, so 6 plus 6 is equal to 12. And boom. So this is pretty interesting, right? In fact, this is a really common operation. Other programming languages, it's so common that other programming languages have a shortcut to increment something by 1, A++. That does not exist in Python, merely because there's a subtle difference between A++, which increments by 1, and ++A, which increments by 1. But one happens before everything else, and one happens after everything else. So that can be very confusing. So in order to, again, make the code more readable, we use the other notation that exists in other programming languages. A plus equals 1. Or let's go ahead and say A is plus equal to 4. That's the equivalent of saying A is equal to A plus 4. Now remember, everything after this hash mark is what's called a comment, right? What is a comment again? Comments are just simply complete. They're just meant to be read by humans, completely invisible to the computer. So the computer does not see this statement after the comment. So this will increment A by 4. So let's go ahead and just cut these lines just to make it a bit easier. So we've got, right, A is equal to 5, B is equal to A plus equals 4, 9. And I'm going to work over here in the idle for a second. One of the really cool things about working in idle is the access to the shell, because basically it's running through this line by line, and now the program is still like active, or it still remembers the results of the program. It's still waiting for the next line. So you can provide the next line by saying, hey, give me the value of what A is. It's 9. So now we can say A plus 1 would be 10. Notice, though, that A is still 9 because we didn't assign the value. A is equal to A plus 1. Print A. That is 10. So, and if there's a plus equals, what do you suppose minus equals does? And if you said to yourself, hey, that's the same as A is equal to A minus 5 over there, then you'd be totally correct. There's also in fact, there's one for every operator, for your 4 basic operators. Times equals, and then there's a divides equals. Divides equals 3. And then there's a, let's see, is there mod equals? A divide. Is there let's find out. I don't actually know if there's a divides operator. Seems like there is. Seems like, right, because it's not an integer, it doesn't want to become an integer. So let's say A is equal to int A. Wait, what's this? Oh yeah, you can totally remember. Same thing applies. So currently A is equal to 3.0 over here. Okay? And here I'm saying take the thing on the right and store it in A. What's the thing on the right? It's turn 3.0 into an integer and store it in A. It's very useful if you want to take a variable and convert it to a different type, right? Because when you're getting input from a user, a lot of the time it's going to be as a string, and if you want a number, you'll want to turn that into a number. And there should be a mod equals. So a mod equals 2, right? That's equal to, that is the same as saying A is equal to A mod 2. So what is A mod 2? What is, well, that's 3 mod 2, right? And what is 3 mod 2? Well, that's 3 divided by 2 and then give me the remainder. 3 divided by 2 is 1, remainder 1. So we store the remainder, which happens to be the same as the quotient, inside of A. Yeah, these look awful and horrible and make you want to cry and run away. But don't worry, I almost never see times. I've seen times equals, but divides equals, double divide equals, mod equal, I don't really see those. 90% of the time, it's a plus equals operation if you've got a shortcut like this. So 90% of the time, if you've got an update operation, you're incrementing, and 90% of those times it's by 1. The remaining 9% of the original one, of the remaining 10%, right? 90% is doing plus equals. Of the remaining 10%, 9 of that is minus equals, and I'd say 1% of the time is when you see any of the other weird operations. So that's these can be a bit of a stumbling block, but that's okay. The more you practice, the more it's going to be drilled into your mind as to how this works.